It is still being recorded. So at the very least, you can do that. Now, I find myself wondering if perhaps I were to... can you do me a favor, Sardaja, and hit the red button, just the red button. Thank you. That's a little bit better to see. So we'll have to kick it this way for today. Then I will go out and I will purchase a cable, because I know all of you have grown up in the wireless era, but anybody who has not grown up in the wireless era knows that a wire is better all the time. So I will go and I will get the wire that will allow me to connect this machine to this system without relying on networking, because networking sucks. So, any questions about pages 168 through to the answer started on 170? 168 to 170. Anybody got a concern? Pardon me? 13. Safety flare is shot upwards from the top of a cliff 200 meters above sea level. There's the equation. Oh, I've lost my stupid little light too. That's a pain in the ass. Where does that live? Screw it. I'll just take a second. Shot upwards. Describe two strategies you could use to determine if this is linear. Well, I gave you one. Is that a linear equation? Right there. How do you know it's not linear? It's got an exponent. So that's one strategy. It's got an exponent. What's the other thing you could do? You could create a table and check it. Or you could put it on a graph. And indeed, you would find if you put it on a graph, it would look something like this. And on a table, it would relate to that. Anything else from page 168 through 170? 6A. The fifth one. That one? Sure. X, Y. What does X always equal? 7, 7, 7, 7, 7, right? Okay. Let's put that on a graph. Where is X equals 7? I'm starting right here. There's 0, 0. Where's X equals 7? I go to the right 7 spots and I hit 7, right? X is always 7. Is X 7 there? There, 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 there. What am I making? A vertical line through X is 7. What if it was Y was 7? It would be up there where Y was 7. Anything else? Once? Twice? Thrice? Okay. Last lesson of this unit, and a lesson that caused a lot of people trouble, even though there is absolutely no reason for it to do so. Function notation. All right. Function notation is really simple to deal with. In grade 9, you had y equaled 3x plus 4. You made a table of values, x, y. You put in values for x, 1, 2, 3. You got values for y, 7, 10, 13. And you put it on a graph. Right? That's grade 9. Everybody remembers this, right? Okay. In grade 10, we have stopped talking about x and y, and we have started talking about IV, DV, or input, output. and functions. Correct? All right. Now, some of you will need to cast your minds back to like your grade 5 math textbook and something that looked like this. Do any of you remember seeing something that looked like that? Zach is nodding his head. Some of you will have. It was called the function machine. And a lot of old textbooks had them. You input a number, you did a bunch of math to it, and you got out another number. And your teacher may have called them input and output, and then never have talked about it again. Where are we today? Input and output. All right? So, what is happening here? I'm going to erase my function machine. Less and less kids recognize that every year. It makes me sad. We move on to what we are doing now. So we add functions, and up until today, we are still writing them as y equals 3x plus 4, right? But what is really happening is I have a dv, which equals my independent variable and some kind of math, right? Right? And as we got further in grade 10, I changed dv to be output equaled my input and some math, right? Here is what happens in the 10th grade. In the 10th grade and onward, we no longer have y equals, we now have this. I heard somebody say, I hate this crap. That's okay. You're allowed to hate it. But hopefully I'll make it easier for you. Please pay attention. Look at that, and tell me what the difference is. This one has f of x instead of y, right? Now again, if I came in here dressed in a top hat and tails, would I still be your math teacher? Would I sit here, get out my computer, and teach you math? Even though I looked different, right? So what do you think happens when we make this equation look different? Does anything change? No, it doesn't. But instead of having a y, we have this notation, which is read as f of x. The f is simply the name of the function. Because sometimes we have 3 or 4 equations that we are dealing with, so they all get different names, and those names are the letter. Just like there's 27 of you in here, and you all have a name. So if I need to deal with Indy, I say Indy. If I need to deal with Zach, I say Zach, because you all have names, so I don't say kid. Does everyone understand? That's the only difference. Okay? F of x is the output, and it is the dv, which means it is also the y value. X is the input, which means it's the IV, which means it's the X value. Now you will notice X appears in 2 spaces. You already know this. If I tell you X equals 2, where can you put that 2? Anywhere you see an X. Okay? All right. Now, let's do this. Let's do this the grade 9 way with X's and Y's. So here is my X. or here is my function, here is what I am putting into my function. What does that part of my function mean? What does that highlighted number mean right now? That is the input. Where can I input -2? Everywhere I see an x, correct? So, that means y equals 1/2 x minus 2. Y equals 1/2 of -2 minus 2. What is 1/2 of -2? -1 minus 2. So y equals -3. Does everybody understand? You should, because that's grade 9 math, correct? Great. So I put a -3 there. Now I'm going to do the same thing with 0. But I'm not going to do all the steps, right? I'm going to change color though, sorry. Y equals 1/2 times 0 minus 2. So y equals -2. Right? Then I'm going to do it again. Y equals 1/2 of 1 minus 2. So y equals -1.5. And then finally, I'm going to do y equals 1/2 of 4 minus 2, which is 0. Can everybody follow the grade 9 math that was done here? All right. Now, for those of you that hate this stuff, this is the only thing that changes. Instead of writing y equals, we write f of x equals 1/2 x minus 2. And this first one in black, x was -2. So I write f of -2 equals 1/2 of -2 minus 2, which equals, we already know, is -3. So the f of -2 is -3. This is an x value, this is a y value. And that's the only thing that changes. Does everybody understand? This saves us from having to say equation 1, equation 2, equation 3, equation 4 if we're working with a bunch of equations. They all get a name so we know which is which. Is everybody good? Okay. So now that you know all of this and you know how it works, let's go down here. Here is my new function. We're used to seeing this written as y equals 2x minus 7. But we're in the 10th grade now, so we don't write that. Now we have this. So if the f of x equals 2x minus 7, and I want the f of 2, what did x change to? 2. So what does this x change to? 2 minus 7, which is 4 minus 7, which is -3. The f of 2 is -3. Now, what is the point on the graph there? 2, and what's the y value? -3. Can everybody do it? Great. You do the next one. I do not want the f of x, which equals 2x minus 7. What do I want? The f of -3, which is 2 times what? -3 minus 7. What is 2 times -3? -6 minus 7. What is -6 minus 7? -13. The f of -3 is -13. This over here should have been an x. So what's our ordered pair now? What do I put on the graph? -3, -13. Can you all do this? Okay. You do 3 while I get my little light back on my pen, because it's really hard to say, what do I want here when I don't have that highlighted dot for my mouse. It'll just take me a second to get that. Well, you guys don't need to see that. There it is. All right. Now, a bunch of you are going to say, oh, Mr. Myers, I'm scared because of the fractions. Do they matter? No, because I chose numbers that work very easily, didn't I? I did that on purpose. This is the function I'm dealing with. Hi, function G. I'm Matt. We're going to do some work together. Okay? Sure, buddy. Let's do it. So, G naught of X, what is the first G I want? 6. Right there, 6, right? So X is turned to 6. So this X turns what? Oh, thank you. This X turns to what? 6 plus 1. That is negative 12 over 3 plus 1, which is negative 4 plus 1, which is negative 3, right? What then is my ordered pair that I am putting on the graph? 6, negative 3. Everybody cool? All right. Let's do the next one. It is the G of what? Negative 3. So that's negative 2/3 times negative 3 plus 1. What happens to the 2 3s and the negative? They all disappear, right? So I'm left with 2 plus 1, which is what? 3. So what's my ordered pair? Negative 3, 3. And the last one is super easy. I can do that in my head. When X is 0, what happens to that? It's 0. What's 0 plus 1? So what's my third point? 0, 1. And then I just go to my graph. 0, 1. Negative 3, 1, 2, 3, 1, 2, 3. And 6, 1, 2, 3, 4, 5, 6, 1, 2, 3. And I connect the line. Is everybody good? Okay, now I'm going to do myself a favor. I'm just going to make this a slightly straighter line because there's something we're going to do next with it. Okay. Is everybody good? Okay, now, number 4, I want you to split your page in the middle. Because there is 2 ways to do this, and you have to know how to do both of them. There's the algebraic way, with algebra, and then there's the graph way. Remember, the function we are dealing with is g of x equals negative 2/3 x plus 1, right? Okay. Using the information in number 3, find x if g of x equals 7. How is this different than what we've been doing? Do I know what x is? But do I know what g of x is? So where does that number go? Does it follow the red line? Or does it follow the green line? It can't follow both. That's why there's 2 colors. does that 7 go there where the red line goes, or does it go there where the green line goes? Look closely at what is highlighted. I'm going to let you think about it for a minute and talk to your neighbor. Where does the 7 go? Green line or red line? And 5, 4, 3, 2, 1, 0. What does it follow? The green line. Because this says g of x equals 7. There is the expression g of x. And that equals 7. So what I do is I write 7 equals negative 2/3 x plus 1. Because you can see here, I do not know what x is. I know what g of x is. Does everyone understand? Now, in math class, how do I get that x? I isolate it, correct? So how do I get rid of this 1? Minus 1 from both sides. So now I have 6 equals negative 2/3 x. How do I get rid of divided by 3? Multiply by 3. So now I have 18 equals negative 2x. How do I get rid of times negative 2? Divide by negative 2, and x equals negative 9. Does everybody understand? We're going to practice it a crap ton. Don't worry. Just make sure you follow this now, right? That's algebra. But we can also do it with a graph. Right now I know g of x, I'm going to change color because I did all the algebra in green. G of x equals 7. Do I know an x value right now? If I hadn't done the algebra, do I know an x value? No. Do I know a y value? Yes. What is that y value? 7. So look on our graph. 1, 2, 3, 4, 5, 6, 7. There is where g of x equals 7, correct? Does everyone agree? And g of x is the blue line, isn't it? So the blue line goes right through right there, right? Everyone agree? What value is that? Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. And it would be 9 if I'd done a straight line here. But I had to go freehand. That's where it should go through, and that is negative 9. Does everybody understand at least a little bit? Okay, let's practice. Now you'll notice I'm being very mean and using fractions here, right? But it doesn't change anything. So, here I have a new function. It is function m. I need the m of 7. So what does that mean? What do I write? 4/3. Then what? 7 plus 2, right? That is 28 over 3 plus 2. That is 9 and 1/3 plus 2. What is 9 and 1/3 plus 2? 11 and 1/3. So what then is my ordered pair for this one? What is the x and the y value if I wanted to put it on a graph? 7 and 11 1/3. What's the next one going to be? The m of 1. So what does that mean I write? 4/3 times 1 plus 2. Well, 4/3 times 1 is 1 1/3 plus 2 is what? 3 1/3. What's my ordered pair? 1 and 3 1/3. And finally, what's different out here? Do I know the x? No, I know the m of x. So I cannot write m anything. What do I write instead? 5 equals what? 4/3 x plus 2. Now what's my job? Get x. How do I get rid of this 2? Minus 2 minus 2. 3 equals 4/3 x. How do I get rid of this divide by 3? Times by 3. 9, damn it. 3, 9 equals 4x. How do I get rid of this 4? Divide by 4, divide by 4. X equals 9/4. What's my ordered pair? No. X is 9/4. So what goes first? 9/4 and 5. Everyone has now seen it with algebra. You've now seen it with fractions. That's about the hardest thing I can do to you in the 10th grade. Everybody cool? Try 6 by yourself or with your partner. Like, just try working through it. I stopped recording probably before I did this. So, it's all going to be on the screen now. It's being recorded right now. It's got all the steps. It shouldn't be too big a deal, right? And then all that's there. I'm sorry about that, ladies and gentlemen. I'm all messed up because the stupid computer's not working right. Sure. Whatever the whole thing is, Jimmy. 175. There's a ton of, because there's so many pictures, it takes forever. Goes all the way to 180. Oh, now there's, oh yeah. Ladies and gentlemen, I forgot something. Everybody look up to the screen, please. See that big orange dot I just put there? That is called a horizontal intercept, because the line crosses the x-axis there. Okay? How many horizontal intercepts does the other one have? 2. There and there. All right? If those are the horizontal intercepts, what's that? The vertical intercept. How many does the curvy line have? The curvy line has just the 1. Everybody cool? All right. Now you're good to go for your assignment or your practice. Meanwhile, I'm going to try and see if I can sort out still what's going on with the... Oh, I've got 2 more cumulatives to mark. And then maybe the last... Instead of taking the last 5 minutes off, maybe I'll hand the cumulatives out. We'll go over it then. It's almost like I've done this before. That's exactly what I'm going to do. I will hand the cumulatives out at 118, and we'll go over them. Not that there's much need to, because amazingly, everybody did awesome. What are the chances? I'd like to think it's because I'm a spectacularly awesome teacher, but pretty sure that's not it. Even though I am a pretty awesome guy. Huh? Do I still like oranges? Of course I still like oranges. No, can't stand them. You know what's weird though, Avian?